Hello and welcome. In this video, we will discuss PYQs of time, speed and distance, and our theme is abstract problems. Let's solve these problems now. First problem says a person walks a certain distance and drive back in 6 hours. Let's see. The distance is AB. So if he traveled to B by walking and comes back by driving, the total time taken is 6 hours. So see, let's say time taken for this distance while walking is TW and time taken for covering this distance while coming back through driving or by using a vehicle is TD. So this complete time is given equal to 6 hours. Let's say this is equation number 1. He can also walk both ways in 10 hours. So if he goes to B and comes back by walking, so goes to B and comes back by walking, right? So A to B, if he goes to B from A, time taken is TW. So obviously if he comes back from B to A, time taken should be TW. Why? Because distance is same. If by walking A to B he is taking TW, then by walking from B to A he should take TW because distance is same. Whether you go from A to B or B to A, it is one and same thing. So it comes out to be equal to 10 hours here. And this is my equation 2. And if I solve this, so from here TW is equals to 10 hours. So TW comes out to be equal to 5 hours. And if we insert this piece of information in equation 1, so 5 hours plus TD is equals to 6 hours. So TD is equals to 1 hour. What does it mean? It means to drive, what does it mean? It means if that person derives from B to A, if that person derive from B to A, he will take what? 1 hour. Okay. Now, how much time will it take to drive both ways? So if B to A driving time is 1 hour, so A to B driving time should be 1 hour again, because distance is same and he's driving both ways. So if we derive both ways, time taken should be what? 2 hours. Hence answer of this question is option A. Kindly make a note of it. I hope guys this is clear to everyone, huh? Let's move on to next problem. Yes, this is a very interesting problem because over here we have to deal with clocks also. So what this question says, a man started from his home at 14:30 and drove to his village. So let's say this point is representing his home and this point V is representing his home. So H2B is the distance that has been traveled by that man. He started at 14:30 hours from his home and arriving there when the village clock indicated 15:15 hours. So this is the time shown by home clock HC, right? And when he reached the village, so village clock was showing 15:15. Okay, so VC village clock. After staying for 25 minutes, so over here he stayed for how many minutes? He stayed for 25 minutes. He drove back by a different route. Now he is not coming back along this route. He has taken some other route to coming back from village to home. Okay, different route of length 1.25 times the first route at a rate twice as fast, reaching home 16 hours. Suppose if he like h2b, this straight line distance was x kilometer and he traveled this distance with a speed of, let's say, y kilometer per hour. If we assume it, then what examiner is saying, he dropped back by a different route. Now the length of this different route, this curved route, is what? It is 1.25x kilometer. And speed, now his speed was what? Twice as fast. So initially he was traveling with a speed of y kilometer per hour. Now he has covered this same distance, this distance 1.25 kilometer with a speed of 2y kilometer per hour. Okay. So as compared to clock at home, the village clock is fast or is slow, what it is. So try to understand this case now. Guys, everybody please pay attention. See, total time taken by him for this entire journey as per home clock, total time as per home clock should be what? See, he started his journey at 14:30, right? And he comes back at 16 hours. Comes back at 16 hours. So 16 hours minus 14:30 hours, it comes out to be equal to what? 1 hour. 14:30. So 1 hour 30 minutes it is. 1 hour or 130 hours, which comes out to be equal to 90 minutes. So he took 90 minutes for completing this journey. So from here, but out of these 90 minutes, he has spent 25 minutes for, like, he has spent 25 minutes in the village only. So these 25 minutes should not be included in the effective traveling. Okay. So effective traveling time. Effective traveling time should be 90 minus this 25, which comes out to be equal to 65 minutes. Okay. See, in these 25 minutes, he has stayed at village. He hasn't done anything. So that is why this should not be included in the effective time of travel. So effectively, he's traveling for how many minutes? He's traveling for 65 minutes. Okay. Now, see, the distance was x initially. Now, the distance has been what? Distance has been 1.25 times. Okay. If the distance is x, now the distance is what? 1.25x. Right? So, see, let's find out this time first. Time taken by that man from home to village. So time should be distance upon speed, x upon y. This is the time taken by that person from home to village, plus while coming back, distance traveled is 1.25x divided by speed. What is that? That is 2y. So x upon y, distance upon speed, is the time taken by that person from home to village by that old route, and 1.25x upon 2y is the time taken by that same person while getting back to his home but by different route. And this is his total time of traveling, and it must equal to what? It must equal to 65 minutes. 65 minutes is what? 65 upon 60 hours. Okay, because x upon y is in kilometer per hour, this is in kilometer per hour, so this is his effective traveling time. So this must be equal to 65 upon 60. This must be equal to 65 upon 60. Now let's solve this further. So 13 upon 12 it is. X upon y can be taken common. Inside we are left out with 1 plus this 125. 1.25 can be written as 125 upon 100, which becomes 200 here, equal to 13 upon 12. Solving it further, x upon y, it becomes, solving this, 200 plus 125 is equals to 320. Or rather than this, let's solve this 125 and 200 puzzle over here. So 25 eights are 200, 25 fives are 125. So x upon y outside, inside becomes 13 upon 8 is equal to 13 upon 12 hours it is. So 13 gone. So x upon y comes out to be equal to 8 upon 12, which comes out to be equal to 4 2s are 8, 4 3s, 2 by 3 hours, which comes out to be equal to what? 2 by 3 hours. Now, what is 2 by 3 hours? What is x upon y? This was the time taken by man from home to village. What is it? Time taken by man from home to village. Okay, x upon y is the time taken by man from home to village. It is x upon y, which comes out to be equal to 2 by 3 hours. Solving it further, so 2 by 3 hours multiplied by 60, it comes out to be equal to 40 minutes. So if he travels from home to village by normal route, by his original route, time taken is 40 minutes. Okay, so he started from home at 14:30. So according to home clock, he started at 14:30. So he must reach, according to home clock, he must reach in the village at 14:30 plus 40. 14:30 plus 40, which comes out to be equal to 14:30. It becomes 3:10. He must reach village at what? 3:10. So 3:10 is his point, is his time of arriving at, or 3:10, or we can make it 15:10. Okay, 14:30 is 2:30. So 14:30 plus 40 minutes is 15:10. So according to home clock, he will reach village at what? 15:10. But according to village clock, he reached at 15:15. So I can see village clock is 5 minutes ahead. According to home clock, he should have reached at 15:10, but according to village clock, he reached at 15:15. So I can say village clock is 5 minutes fast. Village clock is 5 minutes fast. Option D should be the right choice here. Okay, I hope guys this is clear to everyone. Let's move on. Kindly make a note of it, take a screenshot of it. Okay, let's move on. Next question says, two persons A and B running on a circular track. So there is a circular track. There are two persons, person A and person B. At the start, B is ahead of A and their positions make an angle of 30 degrees at the center of circle. So B, let's say A is traveling in this direction and there is B also. B is what? So in angle wise, B is 30 degree ahead. Angle wise, B is what? 30 degree ahead of A. A reaches a point diagrammatically opposite to the starting point. So this was the starting point. So diagrammatically opposite. So this is the diagrammatically opposite point. So from the starting point to this diagrammatically opposite point, this complete angle is what? This complete angle is 180 degree. Okay. When A reaches the point diagrammatically opposite to the starting point, he meets B. So when A will reach this diagrammatically opposite point, B will also be here. He will find B here. Okay. What is the ratio of speed of A and B if they are running with uniform speed? So try to understand the time in which A is covering this angle of 180 degree. The time in which A is covering this complete angle of 180 degree is the time when B is covering only this much of angle, which is 150 degree. Because the moment A started from here was the moment when B started from here. They both are moving in the same direction and they find each other at this point, which is diagrammatically opposite to A. So the time taken by A to cover this 180 degree is the same as time taken by B to cover this 150 degree. Okay. Now over here distances has been shown in terms of degrees. So this is the distance covered by A and this another is distance covered by B. So when time is same, ratio of distances, which is equals to 0 0 gone, 3 6 are 18, ratio of distances covered is also equal to ratio of their speeds, is also equal to what? Ratio of their speed. What is the ratio of speed of A to speed of B? It is 6:5. Option A is the right choice here. It is 6:5. Option A is the right choice here. I hope guys this is clear to everyone. Let's move on to the next problem. This problem says Shahid and Rohit start from the same point in opposite direction. Let's say they have started from point O, Rohit in this direction and the other guy in the other direction, Shahid and Rohit. So let's say this is Shahid and then this side Rohit is traveling. Same point in opposite direction. After each has covered, after each 1 kilometer, Shahid always turns left and Rohit always turns right. So from O to, let's say this is point A. Let's say this is point A. So O to A. Let's say this distance is 1 kilometer and O to B. Let's say this is point B. O to B, this distance is 1 kilometer. So after 1 kilometer, Shahid always turns left. So Shahid will always turns left. So Shahid will go down like this. And Rohit will turns right. So Rohit will go down like this. And again they will travel 1 kilometer. Again they will travel 1 kilometer. And after traveling 1 kilometer, let's say Shahid reached point C. At point C, Shahid will again take a left turn. And he will travel 1 kilometer. And from this point B, when Rohit has taken a right turn, let's say he reached, after traveling 1 kilometer, he reached point D. So at point D, Rohit will again take a right turn and he will travel for how many kilometers? He will travel for 1 kilometer. He will travel for 1 kilometer. So definitely this O was their starting point and this is their final meeting point. What is this? This is their final meeting point. Okay. Now, see, I can see they met for the first time when each has covered. They met after each has covered 3 kilometers. See, if you talk about Shahid, 1, 2, 3. If you talk about Rohit, 1, 2, 3. So they met each other after traveling what? 3 kilometers. So this is all from time, speed and distance. Thank you so much.